Let's see how we're going to do matrix addition. If we have the matrix A, which is 1, 2, 3, 4, 5, 6, and the matrix B, which is 1, 1, 1, 1, 1, 1, in order to add these up, we form the matrix addition A plus B, and all we do is we add each of the respective components of each matrix. So for example, this one here gets added to this one here. The 2 gets added to this one here, and the 3 gets added to this one here, and so on and so forth. So we're just adding up each respective component of each of the matrices. Now another thing to note here is that it only makes sense whenever both matrices are of the same size. That is, they've got the same number of rows and the same number of columns. So for example, matrix A is a 2 by 3, therefore matrix B must be a 2 by 3. So we could say that if M is the number of rows, then MA equals MB, and if N is the number of columns, then NA equals NB. So that's relatively straightforward, and in fact we've seen something very similar previously whenever we looked at vectors. Whenever we added two vectors together, we added them component to component. So the only difference here now is that we've got a matrix, and the matrix here is an extension to the idea of the vector. In this case here, it's a two-dimensional extension. So instead of just having one row, which we would have for a vector, we've now got two rows here for this matrix. But as far as our assembly language code is concerned, all it sees is the beginning of an array, which we can call A, and then the length of the array and the components that are in each of the memory locations. And the same for the value for B, and we go through the addition. So in effect, we could just reuse the code that we generated for the vector addition. So I will regenerate that just now, and we'll have a look at it. On the right hand side we have the calling function, on the left hand side we have the subroutine. So you can see here in the calling function we've got two matrices. So we've got matrix A, which has got components 1, 2, 3, 4, 1, 2, 3, 4, and then matrix B has got the components 1, 1, 1, 1, and then the next row is 1, 1, 1, 1. The length of the matrix is 8, it's got 8 elements, and the results are going to be placed in matrix C, which again is going to have 8 elements. We push matrix A, B, and C and the length into the subroutine. We jump to the subroutine. Now this subroutine is just ostensibly the same subroutine as the vector addition. I've just changed the comments here so that we can remind ourselves we're actually dealing with matrices. So I've called them these comments matrix A, B, and C. So it works through the same way it would do with the vector addition, and it adds the values up and it stores them in the respective memory locations. And of course the code goes through the usual housekeeping of moving values out of the registers into memory, and then goes back to memory and replaces those values. So that's the code. It's quite straightforward, and it's just really the same as the vector addition. So let's see this actually working. I have loaded the subroutine into the ROM and the calling function into the RAM. So let's go ahead and we will see this running. So I've just ran it at full speed, and we should see the numbers coming into register R0 and R1, and the addition will get into register R1. So any second now we'll get the values coming through, and there's 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, and in the next row 1 plus is 2, 2 plus 1 is 3, 4, and then the 5, and then it clears out the registers. And that's it, finished. So we can stop this from running, and we will get in and have a look at the actual values. So it's at 8500, and you can see 8500 we've got the original matrix, which is 1 2 3 4 1 2 3 4, so that's matrix A, and then matrix B is 1 1 1 1 1 1 1 1, and we've got the length, which is 8, and then we have the addition, which is matrix C, which is going to be 2 3 4 5 2 3 4 5. So the matrix addition works fine. Now there's no point for us to go through and show you the matrix subtraction, because the matrix subtraction, like the vector subtraction, is almost identical. The only difference that we're going to have is, instead of adding R0, R1, we're going to subtract R0, R1. So literally there's a change in the line here, and of course there's going to be a change in the actual position within the code as well. So it won't be at 0x13F0, it's at a different memory location. But I've gone ahead and done that. I've loaded it up and I've ran through the example. So we can now do vector addition, matrix addition, and matrix subtraction. So let's move on to look at matrix multiplications. Thank you for listening. I'll get you on the next video. Goodbye.